Up next, we have a very interesting talk talking about tensioning of fuel cell stacks and dynamic tank systems. From HoKon, the assistant of the CEO, I would like to welcome to the stage. Please give a warm welcome to Malte Hopf.
Hello.
Welcome, Malte.
Thank you very much. Yeah, thanks for joining my presentation. First of all, I want to introduce what is HoKon. We were founded in 1997 by Ingo Hopf. We are a small, medium enterprise with 30 employees located in Dortmund. We have got various commercial agency of European and international manufacturers, certified according to 9001, the environmental certification 40001, and the international railway industry standard 22163. And active networking in the H2-Netzwerk Ruhr. It's the biggest hydrogen network in North Rhine-Westphalia. The MACPO, it's a Material Competence Center, and soon the automotive land NRV. So what's the problem definition of tensioning fuel cells? We have got screws are not the ideal bracing system. We have got end plates, and they are subjected to extreme forces at certain points. I will show you later some pictures. We have got no homogeneous contact pressure over the surface sections or over the whole plates. It's also at points. And screws, the power density and efficiency can decrease with bolts or screws. And the setting amounts must be compensated for an elaborated design. So you have to bring in springs inside your whole fuel cell application in the beginning of the engineering and development process. And what's the problem solving from our side? A development of a bracing system over the entire cross-section of the cell. And the solution is a tension band from us, made of high-strength, special stainless steel. And this material is much thinner, lighter, and more powerful than conventional steel clamps. And so you can use it in aircrafts or very lightweight solutions when you need it. And springs can retrofit it at any time with our system. So when you, in the beginning, you see you need no spring, but in the testings, during the experiments, you see, oh, the cell expands. You can refit a spring with our system. And that's the H2 power band by HoKon. You see here, it's a fuel cell in an original scale from our customer. He uses these bands already in the 0 series. He's now make tests and tests in research facilities, and soon MI in the end vehicle. And tension bands reduce the material stress and deformation of the fuel cell components, because you have got the band over the whole plate and over the whole cell and not on points. And tension bands generates a uniform contact pressure inside the cell, so inside the plates and the whole system. And this you see here, it's two cells with the same bipolar plates inside. On the right side, you see the end plates are connected with bolts there. And you see extreme forces prevail, especially on the outer surfaces at the edges, which can lead to failure. And when the red areas crack or burst, the cell will fail. The whole cell can't have the pressure inside and don't work anymore. On the left side, you see the same cell with our tension bands. And during the production process, at the end plate, you can leave more material where the band rests. So the whole force go into the bands on specific points at the end plates. And the next foil show the pressure inside the cell. On the left side, you see it with bolts. You see a lot of red points where the pressure is very, very high, and in the middle, you have got no pressure inside the plates. This can only, also lead to a failure. On the right side, you see the pressure with our tension bands. So you have a very homogeneous force inside your whole application, what increases a higher density of the cell and makes this much more efficiency. And the last thing is the dynamic tanking system from us. We developed something for H2 vessels because they can expand up to 3% in diameter. And when you don't have a special construction there, your tank can get cracks on the outside or the tension band bursts. So the connection must absorb this dynamic, that it's also safe over the whole lifetime or life cycle. And how I told, otherwise the clamps burst or the vessel gets micro cracks on the surface, so hydrogen can go outside when you have got some electronic component there. There could be a fire, explosion or something else what don't relate to the safety issue on these vehicles. And unfortunately, we have got no FEM simulation because we are now in an R&D project for the ideal tank clamp with a research institute. For example, when something fails in the whole system and it don't shut down when you have got the maximum pressure, what can we do that you see it on the clamps? For example, when the spring have got no more way, that there's an electronic device which shows, hey, stop, the tank is on maximum diameter, stop the tanking process. And the results will follow next month, and I would be glad to present it to you in a webinar. And this is a H2 power band on the right side, and the special tension bands for fuel cells on the left side. And I would be glad when you visit us in this hall on the booth E421, where we can show you an original hydrogen vessel with our H2 power band and also a full-scale fuel cell, what we rebuilt after the customer's drawing with these tension bands, and also a functional fuel cell with our tension bands and wooden end plates, which was developed by the Center for Fuel Cell Technologies. They are also in this hall in the ZBT. And please leave your contact data that we can show you our newest products in our webinar next month. And thank you very much for listening. And when you have got questions, please ask them.
Thank you for your lovely presentation,
Thank you.
Malte. So please, people from the audience, if you have a question, raise your hand. So in these fuel cells, Malte, the tensioning, does it allow you to make the membranes thinner in the cells, or what's the main benefit there?
The main benefit is that it's it presses the whole cell simultaneously over. The whole cell get pressed under the same force, and you get no more red areas, whereas a very high pressure or high force what can lead to a failure inside the cell. And especially we have got customers who said it's much more easier to start a serial production with tension bands than with bolts.
Okay, super interesting. So the let's say the loading on the cell, if it's uneven, it will crack or will bend, and that's of course not.
Yes, or inside the cell, when the plates don't get pressed similar together, it could fail inside the cell something.
Okay, super interesting. All right, thank you very much for your talk. Please visit Malte here in Hall 13 at booth E421.